So friends, we discussed different techniques in diagnostics, and we touched upon prognostics also and their overlapping area. But there is one very special technique when it comes to accident or incident investigation. Why? Why it is required? Um, we can distinguish causes into two main parts. One is direct cause. That means direct cause is a thing which is apparent. Bearing failure, cage failure. So this is a cage failure is a direct cause. Okay. If I talk about the motor, then it is because of bearing failure. So bearing failure has become a direct cause. But when I go and do the second level of analysis, I'll say it was bearing failure, but the bearing has failed because of inner race failure or outer race failure. Fine. Now, why inner race and outer race has failed? They also should have some reason. It could have been because of misalignment of the shaft, or it could have been because of oil quality failure, or it could have been because of the procurement which was done. We got into a lower standard or quality of the component. So now if we go into further, you ask questions on all the three notes. Oil, okay, why oil? Because oil was spurious. Again, fourth level we have gone down. Now, why oil level was bad? It was because of quality standards in oil procurement were not followed. Now you find why oil. So you go down till you go arrive at the cause which has got. And if I not only identifying the cause, I should have confidence in that root cause. If I eliminate that root cause, then the failure will not occur. Let us say oil quality. So in oil quality, why it was that oil quality was bad? It is because in chemistry lab there were some formats which are very old thing, and then it was approved also. So what will it was like a institutional failure actually. So that means we have to revamp the procedure of procurement of the oil. So what I will do this, I to remove these causes, we will do 2 independent checks of oil, okay, and everywhere it will be recorded and it will be approved by the higher authority. So these kind of causes should there, and they are called root causes. So root cause analysis is separated from the direct cause, which are apparent when an incident happens, and they go down a way level 5 to 6 to 7, and it requires a investigation approach to come to the arrive at, and there need not be one root cause. There can be more than one root causes contributing to an accident. So let us see what is this interesting approach that we have here. So first of all, if you analyze in your plant the event with safety significance, will be like, suppose if 10 events are happening in a year, there will be one safety significant event. So their quantums are very low actually. But the other one category is the consequential event. Means one is related to other and they have a consequences. Okay. So, but it is not safety significant cause. It could be like your plant reliability got affected, or it is plant availability got affected. So they are lower category. But lowest level of events are their number is more, that the area, it shows the number of the event that fall out of 100. So is more, but they may not require a very detailed root cause analysis. So my colleague and myself, we developed a methodology to handle this situation. That means most of the events which happen in the plant or in industry, they have low level events actually, category. So for them, level 1 analysis means event should not happen. That is the idea. So 10 to 15 days you perform the analysis, 1 month. That is the thing I am giving in the next slide. Here you take 2 months because consequences were there. It may not be safety consequences, but it were there. And then here it is here it should be level 2 root cause analysis, level 1 root cause analysis, level 2 root cause analysis, and level 1, level 2 and level 3 root cause analysis. Since there is a set safety significance, this type of analysis they might take from 6 months to 1 year. That means it requires much deeper material related degradation, organization related aspects, and then simulation and all those things occur. So, but then it can be done because root cause analysis is a resource consuming option. So, for one event I can invest so many resources, but this is 15 days to 1 month. Here it is 1 month or 2 months time, and this is 6 months median time. It could be in some isolated cases 1 year also. So, this is, and then the steps are, so what are the major, it is meant for public domain. So, first important thing for root cause analysis, a decision to start or initiate a root cause analysis. Okay. So, initially sometimes this significance level is available in the beginning itself. Event itself tells, like fire event, ejection failure, it requires a safety significance was involved. So, it should have been done a detailed analysis. So, initiate an investigation, okay. Analyze the fundamental causes responsible for the event, okay, and then review and approve the investigation report implementation. So, these are more or less of administrative and technical nature, mix of, and feedback and tracking. Feedback and tracking is integral part of especially level 3 analysis, and to some extent even consequential event. But for these type of things, they are only frequency why it is happening more, and they are sort of frequent type of event. If they are a frequent type of event, then also RCA will take more time, because every event is having consequences in terms of, if not safety, in terms of plant availability or plant reliability. Any interruption in the plant operation, it affects the plant reliability. Okay. So, now we are here on this, and then let us see how we treat them. First of all, let us understand what are the major procedural framework for diagnostics, root cause analysis, So, because there are many steps. So, as I told you, level 1 root cause analysis should take 15 to 20 days, and we should come out with this thing. And if you have to go ahead and all that, that decision will depend on feedback, whatever we have, and brainstorming sessions are required to do that. So, let us say all the green actions in root cause analysis, they are having, so level 1, they belong to level 1 root cause analysis. That means as soon as an incident has happened, this is just indicative of showing incident and bring your attention to the happening, what has happened. Then site data collection. Immediately after the incident has happened, the first job is first information report and data collection, taking sample, taking the reading, present instrumentation reading, the kind of damage that have taken, photographs we have to take, because they become important evidence for the root cause analysis. Each of these inputs, in fact, interview with the staff, that is ground level, grassroots level staff, middle management level and top management level staff, gives very good information. Then task analysis, and in this task analysis, the major part is creating a chronological order of event, what has really happened, and is there any human factor contribution or common cause potential. Okay. these two are bottom line for any investigation. So, okay. Now, a brainstorming session done, whether to go for level 2 root cause analysis. Brainstorming session means a meeting sort of thing. Here, lot many things have happened, samples would have been taken, samples would have been analyzed, but it is felt that the event was an isolated event and it is not a frequent event, occurring event. At the same time, it is not related to safety thing. So, level 1 we stop, because if you have to go to level 2, we should have, I think risk significant, even it could be low, or even I would say that, if there is a plant availability or reliability is affected, then also it can go to root cause analysis, and if a small safety significance was there. So, how you know that it has happened? It is a precursor analysis done on a PRA, probabilistic risk assessment model, and then feedback is generated. So, we have brainstorming session, PRA feedback is there. Now, that will, these two things together, it will tell you whether to go for a level 2 analysis or not. So, every stage we have to report this event to higher administration management, but if it is at level 2 or level 3, then regulators also should be taken into the confidence and report should be communicated. In fact, they are the one who can take again call. No, you should not go, you should go to for this event, you should go to the level 3 also, because there are some consequences, okay. Or they may say, okay, good that you have stopped. They will either agree or they may ask you to put it in the next category actually. So, now level 2 is what? Decision for level of next level 2. So, it has come here. Now, incident walk down. So, incident side walk down, that means initially it was for the close information collection. This requires repeated walk down to the or simulation to be performed. There could be 1 or 2 or more studies also. It could be one thermal hydraulic study, or it could be, so it is level 2 accident. That means risk significant was, the element was less, or reliability significant, but it was there. But at the same time, so we will go for level 2. It takes almost like 2 months, 1 month to 2 months time, okay. And then again, if we do further and we see that no risk significance was there, so we go to the level. This we might know right in the beginning also, or it may be going from one stage to another stage, we will know. So, brainstorming for level 3 analysis, and then thermal hydraulic analysis. Then, so here what we are saying is, at 1 or 2 point we needed a focus investigation, and therein we involved either the human factor studies, thermal hydraulic studies, structural analysis, institutional factor analysis. So, all those things are there, and that form part of, because each of the analysis, it takes some time, like finite element modeling for structural thing. It takes time to model the whole thing, and then finally having a discussion on that, going to the expert, talking about that. And if it is a quality related issues, that also it will go to level, because it is either it will be known in level 3, level 2, or we have to go to level, because quality is such a fundamental characteristic, it should not be compromised. So, it is better if any quality related issue is there, it should be taken to the level 3 analysis. And at every stage there is a feedback mechanism, for corrective mechanism. And then feedback and monitor after level 3. This is a monitoring and feedback is a very important thing, because the event should not happen, whether it is level 1, level 2, level 3. It should not repeat, especially the level 3 should not repeat, because the stakes are higher compared to level 1 and level 2. So, this is a broad framework for root cause analysis procedure. The bottom line objective is invest only required resources, keeping in view the safety and reliability considerations. Okay. So, having seen this, now let us try to see in a chart like thing, how we'll know whether it is we should go for sure about level 2, level 3 and all that. There should be some mathematical indicator. So, we know that at the bottom line, it is a very resource intensive exercise, and it can be done only by domain expert and some special experts in their own area actually. So ranking is very important, and for ranking what we can do is, we know that risk is equal to, I am putting it in very simplified form because we want to get on to the objective that we have. So risk is likelihood into consequences. If a event, let's say one failure in a year, so one likelihood. Consequences, we lost plant availability, so this one. So that will give us the likelihood and consequences, power failure, one per year. Okay. So, but suppose if there is a safety issue involved here, okay, which had threat to the plant, okay, so it becomes a risk significant. So it ranks high on this level. So we have consequences here and likelihood here. So likelihood and consequences, and you do it qualitatively or quantitatively. For example, in probabilistic nuclear plants, probabilistic risk assessment reports are available, and we can easily get an insight not only on this risk levels, but also in the context of their consequences and likelihood, and their precursor analysis, which we can do on event tree and fault tree. So good insights are available. We use their quantified estimate, and we can what we mean by high, medium or low, we can put a figure. High means 10 to the power minus 3, medium is 10 to the power minus 4, and low means 10 to the power minus 5. We can see like this. Sorry, this is likelihood, and high, medium or low, their consequences. So consequences could be that the core cooling affected, medium time is some safety system affected, and the process system affected, consequences. So likelihood means here, as I said, 10 to the power minus 3 high, 10 to the power minus 4 medium, and 10 to the power minus 5 low. Okay. So once we have done that, we have this risk matrix available here. So when consequences are high and likelihood is also high, so what will have? Level 3 analysis is required, and we are conservative enough to for medium class also we do level 3 and level 3 here. That means likelihood high, or even if consequences high, we do level 3. But if it is a medium, both are medium, that is consequences and likelihood, then we will go to level 2. And again conservatively, here also if consequences are high but likelihood is less, even we go for level 2. So here also likelihood is consequences low and likelihood is high, so we go for level 2, and these are things reserved for level 1 analysis. So now we have created a complete framework for level 1, level 2, level 3 root cause analysis, and this was created by my colleague and at BARC and myself, and probably this should be followed. Maybe it might be translated in one of the standard that we develop in India itself. So and now for level 1, level 2, level 3, though I have discussed, but I am putting in black and white here. Level 1 root cause analysis may take from 15 days to 1 month, while level 2 root cause analysis 2 months, around 2 months actually, and level 3 6 months to 1 year. These are not something formalized frequency. Industry can have their own judgment on this, but for us it was experience on root cause analysis when we did in our plants. We got this thing, but the process is for sort of formalized. Only judgment will vary for a domain or this thing. So now, since we are talking about why 3 levels. In fact, justification has to be put when we offer a framework. So the first, let us see the incident happen. So level 1, 15 to 30 days. This is a complete chart. And is risk level, is risk and reliability high? No, stop it here, level 1 itself. But if it is high, you go to level 2 RCA, and then you weigh it. Is it very high? Then you go to level 3. Otherwise, if it is no, level 2 you stop. Level 3 root cause analysis 6 to 12 months you take, and corrective action program is very important. Root cause analysis will not be over till corrective action program is implemented and feedback program is also institutionalized, so that we see that this event is not recurring. So here we justify the why 3 levels, because every event cannot be subjected to a detailed root cause analysis. But at the same time, any event and every event cannot be limited to brainstorming. There should be some serious scientific, technical and engineering element which gives us enough confidence that okay, this failure will not occur. RCA's main objective is that particular failure should not occur, and we can take the decision right in the beginning that we will go for level 3, because things are known, it is a safety class. If it is not safety class, reliability class, or if not, then it is general class, it does not have much consequences. But sometimes the root cause and analysis, the output can reflect onto other equipments modification also, corrective action program for not only that component, but because suppose if some relay was being used in certain location and it has got into the root cause analysis and there are some finding, in remaining the coverage of the results will be applicable to other components of the plant where the similar relays are, and the similar relays will be replaced. So you can see there is a huge benefit if we do the root cause analysis. One root cause will be an opportunity to do modification in or upgradation in many places. So this is the power of root cause analysis program. Another power of root cause analysis program is that most of the techniques of fault diagnosis or prognosis, they are useful here actually, you know. So root cause analysis is not something that one technique, no. If it is an electronic component, one technique. If it is a mechanical component, B, C, D, so many techniques are available. We have to decide which tools and techniques is working for us actually. So now if I have to see different techniques, tools and techniques, site and data evidence, though because each steps we have to do this one. So incident data and collection from RCA, advantage, it keeps a record. Even if you do in future some more analysis, this record is very useful. Inadequate coverage of data often lead to wrong assessment. So this step is very important. As soon as the incident happens, the root cause analysis engineer or the authorities should collect the information from the site. If these informations are lost, like aviation accidents, if we do not collect the information and from the root cause, we will not be do a proper investigation. Okay. Organizing the evolving event propagation chronological order. This is the important thing. What has happened? What was the sequence of event? What was the intervention level? All those things should come out in a 1.5 page to 2 page chronological. Every minute detail should be recorded. And the salient feature is we are getting important information, stoppage of time on that recording, and now this becomes a common document available for discussion anywhere and everywhere. And this should be subjected to correction if any new information is available or some information needs correction because of some other evidence. So advantages, these two together provide the platform for starting a root cause analysis. Change analysis. Change analysis broadly identifies deviation from. So when site informations were collected, what were the changes that were recorded in the control room? Even those charges, trends, that also should come as part of root cause. And this is the most important thing in any, especially for safety critical system, the barrier should not be compromised. Safety barriers or safety level should not get compromised. I will add safety levels also should get compromised. So this analysis also should form part, and in the subject incident, we should be able to say that no barrier, resilience was violated or compromised. So this step checks. The advantage of this is barrier checking is also done because they are safety provision in the plant. A systematic assessment and review is available on performance analysis. Now next is cause and event. I mean, like one example is fishbone analysis or any technique. So here we are talking about techniques and tool, and salient feature is let us say fishbone we have 80-20. So this must be interesting from certain event. It may not be applicable for another event. Another event might lead to a different use of the tools like FME, DA or some other modes and all that. And then finally, advantage, cause and effect. We have documentation is provides a rule-based approach for this thing. PRA mapping. First is it is salient feature as precursor tracking, and then having a production rule-based development over here. Advantage is systematic knowledge in PRA can be readily used, and further notes can be opened for going into the details that might help the modification in PRA model itself with the data availability to improve the PRA model. And this is an integrated approach. Okay, so a PRA and a diagnostic module, it will create a platform for future analysis also. Common cause potential assessment, I need not emphasize more because this has been noted, and every event should be subjected to its common cause potential in a root cause analysis, and we should be able to say no, there was no common cause potential, because saying no and yes also requires a detailed analysis. Okay, so and common cause consideration, it could be for reliability, it could be for risk and all, and then risk potential for level of RCA. Of course, this comes in the beginning, and that distinguishes from level 1, level 2, level 3. And risk matrix provides a guidance, advantages. Risk matrix key to determine RCA. So, what we discussed today, that we can easily do root cause analysis, and suppose if we have a like failure mode effect analysis, FME DA, I would say, this is a family and FME DA, then it's a salient feature that we have discussed, and we have had a dedicated presentation on this. Advantages, this is a documentable technique. Okay, only issue here is this does not this may not provide a good framework for common cause failure analysis, but because it is a component based, mostly it is a component based thing. Human factor and all, they have to do separately and plug into over here. Human organizational factor is an important thing. The available literature should be seen, and in a root cause analysis, because if any human or organizational factor comes, then it is a serious issue, and it requires a focused and policy view, and have a policy structure in place. And plant simulator, you can do checking of these things, and human factor means man machine interface. So machine and human factor consideration should be checked on this. Then scenario simulation on a plant simulator will help us to not only that particular event, but we can see spectrum of events which are around that event that we have, that is the subject event. So it will provide more, and it doesn't interfere with the normal operation of the plant because it is being done on the simulator. And apart from training and qualification, simulators have been found to contribute to human research. So this is the potent force, you can say, for improving the safety. Now we discussed about barrier analysis. So this has been shown like a physical barrier. We have level 1, level 2, level 3 barriers. Physically also we can see there is a reactor, the pressure vessel, then there is one level of defense, and then in the overall casing of the thing. So this should not come in line, because whatever hazard was being protected, that will find its way out into the public domain. So barrier should be maintained. Multiple barrier ensures safety. Okay, so that alignment should not happen. This is a simple message that is communicated. So for that we have to identify the hazard, identify the barrier and its qualities and how it is being maintained, evaluate reliability of the barrier, evaluate the outcome. If they come in line, 1 or 2, even if 2 come in line, this one is closer by. So how it is going to protect fully, or it will be partial breach, it will allow actually. And have the complete diagnostics recorded, cause and effect, and evaluate the corrective action program also for this. So this is an important concept, because we have to ensure safety. Okay, so this is about root cause analysis. And this is International Atomic Energy Agency in their document, they have given this form. So sometimes when, as we are discussing, if we do a level 1 root cause analysis and record our observation, we will get an idea whether we should go for level 1, level 2, level 3, because here we have to answer all the questions like event title, then safety performance, occurrence, what fail or perform equivalent, then occurrence title, what is that occurrence title, personal this thing, and all, and then safety problems, direct cause, what was the direct cause, and how we can come down to the root cause. That procedure has been given. It is open document, one can see that. So this is one sample, because we have been talking about root cause analysis. So how a form looks like. And then, as I mentioned for FMEDA, this is just phase of the root cause analysis. There will be many exercises will be going, which will be having its starting point from this form, and maybe a document of ranging from 50 pages to 100 to 200 pages on one root cause analysis will be there to have a satisfactory feedback and corrective mechanism in place. So week 4, this is what I was talking about. My colleague, myself, we had one root cause analysis procedure in support of event investigation, published in 2015. IAEA Tech Doc number 1756, that form I showed you from there. And then guideline root cause analysis, Department of Energy, USA. And then PV were the precursor events, filling machine, one analysis was done, but that was internal report. So I cannot discuss directly anything which I did in my Bhabha Atomic Research Center.